minimum and maximum flow rate and DP ranges. But in the mid set points, they haven't provided us, and they ask us to just convert these values on some software, Daniel, or some other software. But I haven't
Okay,
any idea. Yes.
okay. I understand that you have some data like a flow rate, minimum and maximum.
Yes.
And which other data do you have?
Flow rate, and in relation to flow rate, I have minimum DP in mm of water and maximum differential pressure in of water or inches of water.
So what you need to get is the URV and LRV, low range value and upper range value. Is that what you need to find for your data sheet?
No,
Is a
actually, yes, I understand. Actually, the client requirement is that if my FT is, let's suppose its range is 0 to 750 of water, and against these values, the flow rate are 20 to 50 of SCFD. So in the mid, there is some set point. Uh, if I say 30 SCFD, and at 30 CFD, which DP value I have to consider in between 0 to 750 of water.
this is
So that
for liquids.
can,
This is for liquids.
yes, for liquid or gas. Actually, in my case, it's liquid. Oh,
So we
sorry,
can
gas. Yes, gas.
okay. We can go two ways. One is to try to find all the pressures or the data that you're looking for by hand. Means you have all the formulas and you can calculate every value and then have a result at the end. Or you can also have a template. I have a template in which I just insert. I just type all the values, and they give that template give me the results that I'm looking for. So, do you have any template or any software that you're using right now?
Yes, I have a Daniel Emerson group, Daniel flow, RFS flow calculator.
So, isn't that enough for you to understand, or do you have additional doubts in how to calculate it?
Yes, I have additional doubts that how to calculate, but my senior instruct me to use just a Daniel flow calculator, but I haven't understand that how to calculate. Actually, this
This
is
is
the issue.
this calculator is an online calculator. Or it's a template. It's an Excel sheet or something like that.
It's a application purchased apps, and it provides limited information. Sorry, limited use online. I mean, free to use.
Yeah. Well, let me try. I'm gonna try to share with you a screen and try to make you see how the standard gets to the DP that we need for the transmitter to work correctly, and for the flow transmitter to measure the flow correctly. So let me try to go to. I want to show the screen to you. Which one is it? This one. Oh, you want to see yourself? This here. Some is in Spanish and other is in English. So it's because just a moment. Okay, let me go to here. This is in
Yes.
Spanish. No problem. Don't worry about this because then I can share this with you in English. But let's go essentially to the step-by-step way to get to the DP ranges.
Okay.
So, but this is the standard that we use normally for calculating these ranges. You know this standard?
Yes, I know.
Okay. And you have the PDF with this standard, or you have it?
Yes,
You have.
yes, I have searched before on Google. It's free. Its PDF is available free, really.
Yeah. Yeah, and it's in English. I have it in English, so I translate this into Spanish for my own from my own understanding and for teaching others in Spanish. But in English, I don't have it yet. So some material here is in Spanish and some other in English. So this can be very confused or difficult to understand. Don't worry about that, because in a moment I'm going to show you my calculation template. And in that calculation template, you can just type the values and get to the bit range that you need.
Okay.
So this is essentially the main calculation formula for math flow. This one.
Okay.
All of this value here, all of the C factors or data is named here is discharge coefficient. So you need to have most or all of these factors. This is a discharge coefficient. This is a expansibility coefficient. This is, you have to calculate the area. This is area calculation. This one, this formula
Yes.
here. This is
Yes.
area calculation, and this square root is just to calculate flow using dp delta p, and density. This
Okay.
one, this one is beta ratio, which is the ratio between the bore, orifice plate bore diameter, and
Yes.
pipe diameter. You know,
Yes.
so it's a relation to the 4 power here. So you need to understand first. You need to understand clearly each one of these parameters. You know, do you see this formula before?
No, I haven't seen this formula before.
Okay, good, no problem. So uh, it's a good start. So yeah, I know that you haven't seen this before, but don't be afraid because it looks difficult. But with the
Yes.
practice, you're going to become familiar with this with all these parameters, and then you're going to do it very easily, no problem.
Okay.
Well, it's gonna take time. It's not gonna be today. So you will have to practice. I didn't understand this in the same day. In one day, I didn't understand this. So I have to go through the standard, read a lot, practice, and then I started to understand better. So now it's not familiar to you. Maybe it looks very difficult, but you're going to see in the future. You're going to see in the future that this is going to be very easy for you. So no problem.
Okay.
So this document, I'm going to share it to you. I'm going to share to you a document with a step-by-step, um, the step-by-step guide for you to read and to understand.
Okay.
So in English. So
Okay.
let me go. Now, this is fundamental rules. First, you need to understand this to have this formula. This is formula
Okay.
for mass flow according
Okay.
to ISO
516.
61. This is a global standard used for DP ranges calculation and for selecting orifice plates. This one. So it's going to be very useful to you as it is to me. So once you have this formula and you understand each one of these parameters, then you will have to go and understand some fundamental rules of ISO, which is that beta ratio should be or must be, just for this for the calculation to be validated, and to be good. So beta ratio should be between 0.1 and 0.75. Did you know that?
Yes, its range. I already know the in standard. Standard ranges I know the beta ratio standard.
Yeah. Okay. So Reynolds numbers should be equal or higher than 5,000. And
Okay.
some other things that are not so important right now. So
Okay.
okay, let me go. This is repeated. Okay, this is repeated. Okay, this one is repeated here. Oh, let me put it delete it right now.
Okay.
Okay, just a second. Okay, if you are out of these limits, so the calculated the standard do not guarantee the accuracy of the calculation. So for the standard to guarantee the accuracy of the calculation, so you must fulfill these parameters, these ranges. Reynolds numbers should be higher, greater than 5,000, and beta ratio should be between 0.1 and 0.75. This other one is discharge coefficient. This one, discharge coefficient. So you can either calculate it, or you can have an estimation of this discharge coefficient. Let me check here. This is a method to calculate it. This one. So for you to have this, always try to remember the flow mass flow formula that we recently saw in the beginning, and this is a discharge coefficient. This is a very important parameter that you have to use for the calculation.
Okay, sir.
So you need to have this is not a value that ISO is fixed by ISO, but is calculated by this equation called Reader-Harris-Gallagher.
Okay.
This is just a theoretical overview. No problem.
Okay.
Just in ahead, we're going to see a little bit of action. No problem
Okay.
about step by step how to do it. So, but first, it's, you need to understand, or you have to have a very small, a minimum understanding of what is every parameter.
Yes, sir. I
So this
understand.
is a discharge coefficient. It's not fixed by ISO, but it's calculated. Yeah. Or maybe
Yes.
when you are just you don't know this factor or this parameter, you can just estimate it. You can have for just to start the calculation, you can use an approximation, and then go ahead. Then you can adjust the later.
Okay. Sir,
This is
actually,
other.
sorry to interrupt you. The discharge coefficient usually given in the orifice sizing, which we have received from some vendors like Emerson or some other vendors. From
Yeah.
there, we have received orifice sizing sheets.
Yeah. Normally this data, the vendor, supplier of the equipment, they should give you this information for you to validate or the selection. That is a must. They must do it. They must give it to you. If they don't give it to you, you have another option, which is you can calculate it by this equation, the equation of Reader, Harris, Gallagher, and it should be accurate. If you do it by this method, and you insert the right parameters.
Okay.
So here is a recommendation, or maybe a typical range that you can use in case that you don't have this value. Is normally between 0.660 or 0.0.62. But normally the standard says that you cannot assume this as a constant. So you can use it at the beginning just to start the calculation, but later you must find the accurate number for this coefficient.
Okay.
This is another one, which is the expansibility, the expansibility factor. This one
Yes.
is also used in the formula. Yeah, expansibility factor is mostly used for gases. For liquids is 1.
Yes.
For liquids is equal to 1, but for gas or steam, you need to use this formula, this one. So
Yes, because yes, gases and steams are compressible, but liquids are incompressible. That's
yeah,
why its value is one.
yeah, liquids are a little bit incompressible, but it's I would say it's not perceived. It's very little. So when you have a liquid, you can pump this liquid, and there's a little bit of gas or something inside, but is I don't know how you say, when it's so small that you don't have to worry about it.
Okay.
So this is another factor, another parameter, which is K, which is specific heat ratio. This one. This is also for gases. Factor K. Um, this is another that data that you must have, and this one is pressure,
Okay.
upstream pressure, in absolute downstream pressure. For
Okay.
this calculation, you don't need P2. You don't need downstream pressure, only upstream pressure.
Okay.
And this is all this is installation conditions. That this is not the matter right now. Let me go here. Okay, let me go here. Let me see where I am right now. Naveed, just a second. Now, just to calculate these two, this is exactly where you want to get, right?
Okay. Yes.
How to find these two accurately? Yeah, just how to find the right values for low range value and upper range value, right?
Okay. Sir, yes, I and one more thing I have to calculate that if my DP range, differential pressure range for orifice is, uh, let's suppose 0 to 750 mm of water.
Sorry, when you say H2O
Millimeter of
of
water
water,
or inches of water.
okay, millimeters of water.
Yes.
Okay, good. Yeah. There's a unit. I understand. There's a unit for differential pressure that we use for these cases. Differential pressure transmitters that are used for flow measurement. I know,
Yes.
but it sounds strange to me when you said mm. How do you say? Can you repeat it,
mm
please? Mm.
of water. Millimeter of
And
water. Sorry.
mm04.
Of water.
Ah, okay, okay,
H2O.
okay, okay. Of water. Yeah. Sorry. Yeah,
So,
I just wanted to be sure that what I'm listening is exactly what you're saying. That's all.
so if and minimum and maximum flow rate also given at these ranges, 0 to 750 millimeter of water. Then if I have to calculate in the mid of the differential pressure, what will be the flow rate?
Well, you need to use.
Can I explain to you well or not?
I think that you need to know. You need to understand. You have the limits. You have the for zero
Yes.
flow and maximum
Yes.
flow, or for minimum and
Yes.
maximum flow. You need to
Yes.
understand how to calculate flow. For example, in the middle.
Yes. Yes.
Okay, but you need to use this formula. You need to use this
Okay.
or the volumetric flow calculation. So once you have delta P, and once you have, for example, the coefficients, or CV in case of
Yes.
valve, but this case is orifice plate. When you have
Yes.
these coefficients, delta P, beta ratio, all these coefficients, the factors, you have the area of the pipe.
Yes.
You can calculate flow for any instance of the flow.
Oh,
Yeah,
okay.
then you will all you have to do to know the flow in any instance of the range. You just need
Yes. Yes.
have these values and just make just how do you say mathematical in physics? Let me remember. You just have to just have to put here to write the values. That's all.
Yes. Okay.
That's all. So, but
Okay. Please.
we can go then to the point. No problem.
Okay.
Anyway, Navid, I'm gonna send you this. What I'm gonna share with you is goal. I do this for payments. Yeah, what I'm talking about the calculation sheet. So people pay for that. But as you told me your current situation, uh, I want to share it with you, and that's going to help you. I hope that it's going to help you a lot. So in that
Okay.
sheet, calculation sheet, you can have this value of intermediate flow in case that you need it. So
Okay. Many thanks.
you're welcome. You're welcome. You're welcome. I hope I can help you as much as possible.
Thank you.
Okay. So this one, then you have let's go. So here comes I think all of from here below is everything in English. So I think you're going to understand.
Yes.
So for for a practical range calculation using an engineering method, we're
Yes.
gonna go step by step. Yes. So this is gonna share this with you. I'm gonna share this with you, so
Okay.
you can have it and you can practice because, as I told you at the beginning, I'm I'm almost sure that you're not going to learn everything today in this time because we only have 1 hour. So I'm going to give you the tools for you to for you to try to understand and to get where you want to go. So
Okay.
this is step one. You understand this. I think you define process flow ranges. You told me that you have the flow ranges given by the client. So you,
Yes.
you have minimum flow, normal flow, or maximum flow, but normally you need only just to get all the URV and ALFV, you need a maximum and minimum flow just
Okay.
to get a minimum differential pressure and maximum differential pressure. So from there, you can find any intermediate value with the
Yes. Yes.
formula or with a sheet that I'm going to give it to you. I'm going to give it to you.
Okay.
So first, you have all this data. Then you select beta ratio. This is the
Okay.
case. In the case that you don't have the beta ratio initially, you can you can select a beta ratio between 0.3 0.76, which are the most common. Try of course to avoid 7.7 greater than 0.7 because it's too high. So we are trying to go below 0.7 and higher than 0.1.
Okay.
Then you calculate maximum TP for TP flow, for maximum TP flow. And this is the formula that you have to use. This is the formula you
Okay.
have to use. Okay.
Okay.
For industrial practice, typical design targets is at this 100. This at this. Just read. You have this one for liquid. These are typical design targets. This one.
Okay.
It's not that it has to be this yes or yes. No, it's that these are typical design targets. So if you
Okay.
calculate for liquids differential pressure and it's beyond this value, you have to try to think about it and just to try to figure out where is the problem or what can you optimize just to
Okay.
try to be between this value. But if the case is special and values can be more than 250 or less than 100, and the flow is measurable, and the DP transmitter is it has the ratio for that, no problem.
Okay.
So then step 4, you have to determine delta P at minimum flow. These are the two values that you need for to have the ranges. Okay, here you have delta P. Okay, this is to calculate minimum flow or delta P at minimum flow.
Okay.
So then at the end you have delta P maximum. Here you have delta P maximum. Yeah, let me go back here. In step
Yes.
3, you get delta P maximum. And
Okay.
then you have with delta P maximum, you find delta P minimum.
Okay.
You only need here, you need max flow, for maximum flow, these coefficients, area, beta ratio, plus density, this one.
Okay.
So with this parameters, you can find delta P maximum. And after that, with the delta P maximum known, then you will have to calculate delta P minimum with this
Okay.
formula. So
Okay.
all these formulas are very reliable because they come from the ISO 5167 standard, which is a world-class standard. So in the
Okay.
template that I have, and I'm going to share with you for free, uh, this template is validated for ISO standard. So
Okay.
it's going to be very accurate, no problem. So then you have delta P minimum, and you have these two values. And then at the end, you will choose or select the transmitter range, and you will have,
Yes.
that delta P transmitters, you have different sensors, or we call it, in Spanish, we call it cápsula, which is something like capsules. Yeah, it's a sensor, delta P sensor. I don't know how you call it in English. How you call it in Pakistan, this one. The sensor, the differential pressure sensor is a diaphragm, a
Yes.
stainless steel diaphragm. It has a silicone liquid inside
Yes.
for the
Yes.
isolation of the chambers.
Mm.
And
Okay.
then you will have the microfarad is
Yes. Yes. Two tapping points we can take, and then the tubings from upstream and downstream.
yeah. So then you have to change. You have to select. Once you have these two, the delta P maximum and minimum, then you can choose the right or the correct transmitter. Yeah.
Okay.
That then you go to the selection of the transmitter. First, you need to have the values of the delta P values, and then you select the transmitter according to this value.
Okay.
Okay. Okay. Again, this is the transmitter should have U or V equal to delta P maximum. This is logical recommendation, and be accurate enough at mm, a minimum pressure. You know
Okay.
that most of the instruments, like differential pressure transmitters and valve, one of the problem is minimum flow. Yeah. So
Yes.
there's a minimum flow for that instrument to measure, or they can measure accurately, precisely. So you must be careful about this, and you can find that with the ratio of this transmitter.
Okay.
Okay.
So this thing we can check from turn down ratio of specific instrument.
Yeah.
Like
So
yes, turn down ratio and rangeability usually applies on flow meters.
yeah, this one here it is. Here it
Yes.
is. So there's a rule here that says that if delta P minimum minus or less than 10% of span, accuracy degrades. It means that you must measure the percentage of the minimum pressure with regards to the maximum with the span. Yeah. So if it's 5 or 10%, So you have to understand, or maybe to inform to your clients that the accuracy degrades. So it's
Okay.
not going to be as accurate as it is in the this one in the tone down ratio. This one. So that's a good data to inform to the clients.
Okay.
So the final transmitter configuration this is an example. Example final configuration is LRB 0 to 100 kilopascal. Which units now that you can see here kilopascal because it's the one that ISO standard use. Then you can convert this to of water. This one,
Yes.
but ISO use kilopascal. So which
Okay.
one do you use in Pakistan?
We usually follow international standards like IS units, international standard units, millimeter of water or inches of water usually.
Okay,
But we
yeah, the
also
same.
use millibar as well.
Yeah, it's the same here. Yeah, no, it's the same here. If we use international systems units, normally is mm of water
Mm.
or inches of water, and sometimes millibar. Millibar for pressure is bar or kilograms of square centimeters, and Celsius degrees for temperature.
Yes.
So what's the problem here? Something happened. Okay, well, these are critical engineering checkpoints, quick design rules. So let's go to the examples for you to see it, and then we can go to the template, calculation template, that I'm going to share with you. So
Okay.
I hope you can use it uh, completely and get to the point just to
Yes.
find what you're looking for. This
Yes.
is an example that I wanted to show you just for practical understanding. Is that in this case, this is a fluid, this water. We're gonna go to the DP maximum and minimum, and you have
Okay.
this temperature, density. This is our data that you must manage, which is pipe internal diameter. Maybe I'm going to share with you. I don't know if you need it. I have a table which just give you all this data for different sizes and schedules. Do you have
Okay.
this type of information or you need it?
No, I have previously I have heard before the standard B16.36, I think, in which the pipe internal dia and their schedule and their outer dia and their nominal pipe size is mentioned.
Yeah, this one.
Yes.
This is ASTM, ASTM. No, this is ASME.
Yes.
ASME.
As
This ASME V36 that one in
yes.
5 dimensions. So do you have this one?
No, I have not this one, but when I have to calculate, I can calculate on Google or something else, but
Ah, okay,
not in
okay.
a compiled form. Not in a compiled form like this sheet.
Okay, no problem. Only for this time, I'm gonna give you two for the price of one. Just kidding. Okay. Now I'm gonna send this to you for you to have a quick reference of
Oh,
the pipe diameters.
yes.
Use it. No problem. Okay, so this one, you need to have the in pipe inside diameter, maximum flow rate, and here maximum flow rate is 100 cubic meters hour, and minimum 20 cubic meter hour. Then let's assume, for this example, we assume that beta ratio is 0.5. This one is discharge coefficient is 0.0
6 1.
61.
Yes.
And expansibility factor is 1 because it's a liquid. As I told you
Yes.
before, for liquids, expansibility factor is a liquid. Sometimes it's not shown in the formula because it's equal to 1.
Okay.
So now when you convert flow to, you need to go step by step and start to make conversions for adapting the units to the formula. Yeah, because you
Okay.
cannot use any units. If you use any unit different to this one, or you mixture, or you mix units, you're going to have a bad result. So the final result is going to be wrong. It's going to be
Okay.
incorrect. So you need to convert these values for the formula to work. So this
Okay.
step by step is going to help you a lot to understand it. Okay, then you just convert this one to cubic meter seconds, because now it changed from hour to second. That's all. That's
Okay.
it. This is a formula for mass flow, and then you multiply if density for by density by flow,
Yes.
and then you will have here this mass flow in kilograms per second.
Okay.
See, this is what the needs. ISO needs kilograms per second just to use this in the formula. Determine
Okay.
orifice diameter. This is for just to find the diameter of the
Four.
orifice plate. Yes, the
Yes.
bore
Yes.
diameter of the orifice plate. This is the formula to find it. Now you can see here, you have D inside diameter, and you have beta ratio, but you need to have this one, so which is the bore diameter. Then here you have to replace, and D is equal to this, and you find the bore diameter. Then
Okay.
you have to calculate. Then here you have to calculate delta P at maximum flow. This using this formula, you go and get delta P. This is rearranging. As you said, rearranging this formula here. You
Yes.
can come here, and delta P is equal to all of this. Yeah. So you will have
Okay.
delta P for maximum flow. This one. This is mass
Okay.
flow, maximum mass flow. So you can have delta P. Step-by-step substitution here. I'm not gonna go through that, but you go here to delta P substitution here. If you see here, you have in the parentheses here, you have some values. These are discharge coefficient, and this is area calculation. This one.
Okay. Okay.
This is area calculation. So this means when it says here step-by-step substitution, it says that you first calculate area. So you're going to substitute, or you want to calculate by pieces. First
Okay.
one, this one area. Yeah, you have area. Now you need to go and just multiply this one, which is discharge coefficient, this by area. And you have this value. Now you have the number for this calculation. You have this value. You already also have the mass flow. Now you need
Okay.
then mass flow, which is here, mass flow divided by the result of this one. You have this result. You have 23,136. Then you have to square it. This one, as you can see here, this is a square
Okay.
root. Oh yes, to the second point. How do you say this? When it's to the second power, or something like that.
No, in Pakistan we also say scare. Scare.
Square. Yeah. Okay.
Square.
This one. Then you have just to square it, and you will have this result. So this value that you got here is this one. Is this one. Now you need to solve this one.
Okay.
Are you getting it?
Yes. Yes. I got the point.
But anyway, as I told you, you then have to go step by step, try to understand where everything comes from, use the calculation sheet, validate it, and you will have a much better understanding.
Okay.
So that now you have the area, you have the discharge coefficient, you have the flow. Now you have the whole package of data for this one. This becomes one number, which is here, which is here. Now you need to have you need to solve this one.
Okay.
Yeah, let me go here. Let me go here. This one. Okay, this one with yeah. Let me see here. What is the situation? This one. Yeah, one minus this one. Now you're solving this one this division, this one. You are solving this one, and this is the result. Now you have the number for this value, and two times the density, I think that's a direct calculation. And at the end, this one that is here, two times the density, and then you calculate. Now finally, you calculate delta P. Delta P.
Okay.
Yeah, all of this, you will have delta P, which is 250,000 Pascal, you know?
Okay.
And delta P maximum, now you have delta P maximum. This is the value that you want to convert to of water, this one. But this is
Okay.
the value for delta P maximum. This is the value that you're trying to find and to write in the data sheet for calculated
Okay.
range. You know?
Right, sir. Yeah.
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 Yeah. Then you write this, you convert this to of water, and you will have already URV in here.
Okay.
URV.
Okay.
Now, just to find minimum delta P for minimum flow is much easier. You know, the more difficult step is to find delta P at maximum flow, because there are many steps, there are many conversions, and but when you have delta P maximum, getting or finding delta P minimum is much easier, as you can see
Yes.
here, because you have delta P minimum is related to delta P maximum, which is here. Just here, multiply by this one. Now you solve it here. This is Q minimum, okay, which is flow rate, minimum flow rate, maximum flow rate. The relation between those two is 0.0.2, and then this is
Yeah.
directly calculated. No, we don't have much. We don't have something extraordinary to explain here, because it's direct. Yeah, you know.
Yes. Yeah.
So
Yeah.
you have delta P minimum, which is delta P maximum, multiplied by the relation between Q minimum and Q maximum, and all that squared. That's all. And then you have delta P minimum. So the final transmitter range is 0, no, when you select the transmitter, 0 kilopascal to 251 kilopascal.
Okay.
Range. This is a engineering unit. This one is transmitter, as you can know, as you should know. This range is a engineering unit. It's
Yes.
not a physical unit. It's not a unit used by the transmitter, but this means this flow range in cubic meters per hour means that just to measure this range of value, you need to have
Yes.
this range in the transmitter. That's all.
Okay.
So DP at minimum flow is 10 kilopascal, and DP at maximum flow is 251 kilopascal, which means that if you have a flow below, or a differential pressure below 10 kilopascal, it's not so accurate.
Okay.
Not so accurate. So then you got the DP value that you need, and just when you divide the maximum flow between divide the maximum flow for by minimum flow, minimum differential pressure. Sorry, when you divide maximum by minimum, you have the turn down ratio.
Okay.
Yeah. Now, transmitters should be able or must be able to manage this turn down. So transmitter
Okay.
must be this turn down or better or higher to
Okay.
be accurate. So if transmitter is, for example, 10 to 1, no good. It's not
No
gonna
good.
it's not
Yes.
gonna work properly. It's gonna measure, but it's gonna have a big mistake, a big deviation.
Yes.
So transmitter must be able to measure in this turn down ratio.
Okay.
So
Sir, we usually mention turn down in flow rate also. This is the turn down on DP, but we can also mention in flow rate units as well, like DP at 10 kilopascal minimum flow will be, for example, 30 metric cube per hour, or at maximum flow rate, let's suppose it's 50 metric cube per hour. We can also calculate turn down for, yes, 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 this point.
no, this one, here you do not use tone down ratio because normally flow can go from 0 to a positive value. From it can be 0.1, 0.1, 0.2, but the difference is that in those values it's not accurate. You know,
Okay.
tone down ratio means that the measurement is very accurate in
Okay.
that values between 25, let's say between 25 kilopascal, for example, to 251. So in that differential pressure ranges, the measurement is very accurate. You know,
Okay.
that's why here when you mention flow range, it comes from zero, from nothing, to 100 cubic meters is a real value that the transmitter can measure, and it's the real value that the operator is going to see in the HMI. You
Okay.
know, but it's not so accurate in those values. That's why you
Okay.
don't apply turn down ratio here. This is only range. This is only
Okay.
the range of the flow for the operator in engineering units. This
Okay.
one. Tone down ratio applies for is applicable for orifice plates, restriction orifice, and for safety, pressure safety valve, and for control valve.
Okay.
This one, and it's very important parameter because help you to select the right valve, the right CV for valve, and the right differential pressure transmitter in this case.
Okay.
So this means that you need to have a transmitter that can manage this range, this tone down ratio, for the measurement to be accurate.
Okay.
Well, now let's go to the sheet, just for you to see. This is the sheet I'm going to share with you. Okay. This one. Okay. The good news is that is in English, no problem.
Okay. Okay.
It's a good news for you. It's a good news for you. So it's in English.
Okay.
Here, when you have this template, this calculation template, you just have to come here and type, for example, 1,000 kilograms. This is the density, minimum flow, the flow that you are given by the client. They give you this information. Minimum flow, normal flow. Here you have normal flow is an intermediate value, and maximum flow.
Okay.
Then this template itself, when you enter these values, automatically they calculate minimum flow in seconds. They convert. They convert
Okay.
directly here.
Okay.
You can see that this cubic meter per second. Here is cubic meter per hours, and here
Yes.
is cubic meters per second. So it's good because you don't have to calculate it separately. Yeah.
Okay.
So you only enter these values, and it's gonna give you some conversions instantly, so like this one. And additional to that, then here you have to enter. You have to enter the value of 45 bore uh, pipe internal diameter, this one. And these two values are going to give you this. You have to put it by hand. This is not automatically converted. You have
Okay.
to enter this value. I'm going to give you the table that you recently saw. I showed you
Yes.
recently. So from
Yeah.
that table, you can have the pipe internal diameter and calculate this one, 45 bore.
Okay.
Anyway, if you have a doubt, you go to the step by step calculation that we recently saw,
Yes.
and just calculate it. Calculate 45 bore. You come here and just ingress, or you enter this value here, and this is going to calculate automatically the here below. This is beta ratio. You know, they calculate beta ratio. They calculate the diameter inside internal diameter in meters. This is another value that you need for the formulas. But
Yes.
with this calculation sheet, you don't need to manually calculate because it does it automatically. So you don't have to
Okay.
do that. So it's gonna give you, but in case that anyone in the company or maybe any client asks you about for this data, for these parameters, for example, they ask you, but tell me how many meters are 650 millimeters. So you have here the value. So it's automatically converted.
Okay.
And then uh, here below, you have the conversion. You know, can you see? You have
Yes.
Q minimum. This is dp in kilopascal. Here you have it in millibar. This one is
Okay.
inch of water. I don't have here I don't have millimeters of water, but you
Okay.
have inches. Then you have to convert it. If you want it in millimeters, you can
Okay.
convert, and that's all.
Okay.
So let me check something here. Let me check something here. Okay. Now, if you compare, you have the same values that we used for almost the same values. With this one was 1997. 997 was 20 millimeter, 20 cubic meters per hour, and 100 cubic meters. And this is the
Yes.
results: 251
Kilopascal.
kilopascal and
Yes.
10 kilopascal. And if you want an
Yes.
intermediate value, as you asked me before, if you want an
Yes.
intermediate value, what all you have to do is to come here. And for normal flow, just type here the flow that you want to evaluate.
Okay. Okay.
No,
Just put in the normal flow cell if I
yeah.
want mid-range value.
How much
Uh,
here?
Actually, it's in SCFD, but I have to convert in meter cube per hour.
This one. Do you want me to change this value?
Yes.
Let's suppose
It's
that we have 80
okay.
cubic meter per hours. Then you go
Okay.
back, you go below, down here below, and you will have that for that flow. You have a differential pressure of 160 kilopascal.
Okay.
So,
But
so
I need to follow. I need to put all the conditions first. Then I have. Then we get the result. Let's
yeah.
suppose in my case the conditions is different, so I have to follow step by step in this
My,
sheet,
my
and then
yeah.
yes.
My recommendation. in order in order for you to understand this very clearly, it's just to have to read and check very carefully the step-by-step calculation sheet. You know,
Okay.
go through the sheet, go step by step, try to understand very clearly where everything's come from,
Okay.
and then use this one, use this sheet. What I would
Okay.
do if I was you, I would do is to practice with different values here, different values calculated by hand, and then come to the calculation sheet and validate it, just
Okay.
to make sure that you are doing it correctly.
Yes. Right, sir.
So yeah. So and here is this one. This one here is for gas. You know, if you want to calculate gases, you can come here because difference between liquid and gases is gases is compressible, and
Yes.
some parameters like expansibility factor it varies, is here.
Yes.
So if you have the, for example, an isentropic exponent k different of 1 or 1.2, the variation, the difference is very high here in
Yes.
the final results. So this must be accurate. This isentropic is exponent k. So these two uh, are good for you to calculate gases,
Okay.
steam, and liquid.
Okay. Now I got the point and I understand well.
Yeah, I know that you're going to maybe in the future. I don't know when. I'm going to try to make a course of this, a training. I don't have a training of this right now because I'm working with control valve. So on Wednesday, I'm going to have a control valve sizing and selection webinar, but it's in Spanish. So so maybe it's going
It's
to be a little bit difficult for you. Do you understand Spanish?
no, I don't understand, but I suppose that in future I have many interactions with you. I hope, inshallah.
Well,
But
I
I
hope
need
so.
to I need to learn Spanish if if I accept your mentorship.
Okay, okay. Well, no problem. I can. I don't know if my English is good, but I can communicate in English.
Yes, your English is better than me.
But which is the language from Pakistan? The national language,
It's Urdu.
Urdu. It's not English,
Yes, not English. It's Urdu.
but English is spoken in the country. Is a second language, or you speak English because of your job?
Yes, because of the job, it's become requirement because we have to meet the different clients and they understand English. So we have to learn English as well.
Okay, okay. Well, Navid, I have to go, but it's been a pleasure to talk to you and to
Okay.
try to teach you a little bit of what I already know. And I hope this information help you a lot,
Okay. Yes.
and that you get to find this value of these DP ranges precisely, and your clients are happy.
Yes. I hope. I
I hope.
hope they will happy. Yes.
So it would be good if you send me an email where I can send you this information, or if you
O-
want, if you prefer, I can send it to you by LinkedIn message, as you wish.
Okay. I will share you my email address on LinkedIn, and then sir, you will send me the this range calculation template.
Good. Good. Well,
Oh,
see you, Navid. I have to do something else. I have to go. And
sir,
so,
one more thing, if I
huh?
just 1 minute. Yes, sir, it's what do you suggest me, because I am a junior engineer and I have a lot of confusions about work. So what do you suggest how to learn things efficiently and do the work? Because there is a lot of time, there is a work pressure, and we have to do work without any understanding, but we have to submit the deliverables and calculations. So very short time, and instrumentation is very vast, very vast.
Yeah,
I
very
have
well.
around 3 years of experience, but I consider myself that I have nothing idea about it. But I try to learn as much as possible.
I think, well, in this case, what I suggest is to prioritize. In life, we do not have enough time for everything. So we have
Yes,
the job, we have family, we have friends, we have
yes,
our relationship with God, everything. So
yes,
time is short.
yes,
You have to prioritize. We have to prioritize. So what I mean by that is, if you want to become a senior engineer in instrumentation, you must invest a lot of time in learning, maybe individually for free, which is much cheaper, but it's not as fast as you would like to grow in the career. But
yes,
if you can pay a training with an expert, that would shorten the way to the seniority. Yeah.
yes.
But if you have
That
a
is
lot
the
of
thing.
time, yeah, if you have a lot
That
of
is the
time,
that is the thing you have mentioned. That yes, this is the point.
so as time is short, we don't have much time. We need to grow to a senior level
Yeah.
as quick as possible. I don't know how fast do you want to go. So you need to personally and individually to dedicate time to learn,
Yes,
and not to learn from anybody, just to learn from standards. You need to find standards and learn standards, and just to learn with experts.
yes,
You have to learn with expert, because an expert is gonna shorten the path to seniority, to senior
yes.
engineer. But you can
Right.
learn by yourself if you want, as most of the people do. I know
Yes,
that you don't have much resources, economical resources. I know that, but make an effort, because it's gonna be very very convenient, and yes, very convenient for you. You're going to learn very very fast with people who already uh, transit this path
yes,
and made it. You know,
yes,
so that's what I suggest. Not with me. I'm not suggesting with me, but with any expert that
yes,
you can find anywhere. Yeah, maybe for free or paid, but experts will shorten the way, your path to senior level.
yes. Sir, I want to learn the control valve in depth. So, what you offer can you matlab, less price at as much as possible? Less
I know.
price, I will pay.
The situation there, I don't have any problem with lowering, to give you a much better price. I don't have a problem for that. The situation is that now I'm not making courses in English, so only Spanish. So for me to create a course in English, most of all in Valve area, it has to be a lot of people to make it feasible.
Yeah,
To make it
I
feasible, yeah, for this creation to be valuable, and I can get compensation for that. So it has to be many persons, you know,
okay.
yeah,
Yeah,
because I can take maybe 3 months to create fantastic. training for Valve in the English language.
Okay.
Or maybe I can create Spanish courses or training and have a voiceover, a translation, an automatic translation is in English, and maybe it works. Maybe.
Yeah.
So in this case, Navid, the situation is that I'm not creating English courses right now.
Okay.
So anytime, maybe in the future, I will maybe publish or post um, maybe a call for an English course about Valve, and maybe
Okay.
I can see how accepted it is, and if how many people will take it, and then I will just take the time to do it. But
Okay.
now I don't have I don't have a course or training in Valve. So for me right now, my suggestion and recommendation for you is what I told you before. Dedicate time, invest as you can, and you will
Okay.
shorten your path to senior level.
Okay. Thank you.
You're welcome. Later, I will send you the information.
Okay, I will share you my email address.
Okay. Thank you, David. See you.
Okay, thank you.
Wish you the best, and God bless you.
Okay. God bless you as well.
Amen. Amen.